And now I have to multiply one row of the likes together. Matt, you want to work with the top row or the bottom row? Bottom row, fine. All right, so we've got 2 times 2 times 2 times 3. That's the greatest common factor. All right. Over here in the last column, we're working with the last 2 concepts of the day. The first one is the concept of relatively prime. Relatively prime is defined as 2 or more numbers whose greatest common factor is 1. 2 or more numbers whose greatest common factor is 1. So to determine if 2 numbers are relatively prime, that's a pretty simple thing. You're going to go through, you're going to make the factor trees, or list factors, whatever you want to do. Find the greatest common factor. If it's 1, they're relatively prime. If it's anything else, they're not relatively prime. So you've done all the things you need to do to answer this question. So let's look at example 6. Are 112 and 45 relatively prime? Now, we probably don't want to list factors here because then I've got to list all the factors of 112. And that's probably going to be a lot more work than we want to do. So this one, we're going to probably want to break this down by using factor trees. All right, so let's start with 112. The obvious way to break down 112 would be starting with 56 and 2. All right, break down 56 for me. Kevin? 8 and 7. Now, 7's a prime number, but 8 isn't, so 8 has to be broken down again. Break down 8. Caitlin?
4 and 2.
4 and 2. Four has to be broken down one more time. 4 breaks down as 2 and 2. All right, 45. 2 numbers that multiply together to make 45. 9 and 5. 5 is prime, but 9 isn't. 9 can be broken down as
3 and 3.
3 and 3. All right, so over here, I would have 2 times 2 times 2 times 2 times 7. Over here, 3 times 3 times 5. As you can see, we don't have a number in common. There's no number that's in both lists. So that being said, the greatest common factor has to be 1, because 1 goes into everything. Right? And that means by definition that these are relatively prime. The greatest common factor is 1. All right, last thing, greatest common factor of monomials. Now you can see the directions for finding the greatest common factor of monomials is not down there. It too is up there. Step 1 says we calculate the numerical part using any form. So for the numbers, you can list factors or you can do factor trees and find the greatest common factor that way. Easy enough. Second step, for the variables, if they're common to both, meaning they're in the left thing and the right thing, all right, then we just simply take the lowest powered variable with the exponent into the solution. So let's take a look at example 7. The greatest common factor of 12a cubed and 9a squared. All right, since these numbers are small, let's just go ahead and list our factors. All right, Corey, factors of 9.
3 and 3.
3 and 3, and
That's like a big rough.
What?
9.
you can use 9, yeah.
1 and 9.
1 and 9. Kyle, factors of 12.
Me?
You're Kyle.
Okay. Factors of 12. 3
And
4.
More.
12 and 1.
12 and 1.
Remember?
2 and 6.
2 and 6 would be the other one.
Oh,
Thank you.
yeah.
Alright. The largest number that's in both lists is the 3. So for the numbers 12 and 9, the greatest common factor is 3.
Oh, that's
Now I got to do the variables. Alright. First of all, as you can see, we've got an A thing here and an A thing there. It's got to be in both, otherwise you can't even do anything with it. So that's the first part. If it has that, then we just take the lowest powered one into the solution. So here I've got A cubed, here I've got A squared. The one with the lowest power, or the lowest exponent, is the 2. 2 is less than 3. Right, so I'm taking A squared with me into the solution. There you go. Just got to take the one with the lowest powered exponent down into the solution. 2 is less than 3, so A squared comes down.
Why not 3?
If I wrote it out and did the circle thing, A cubed would be A times A times A. A squared would be A times A. There's 2 A's in both lists. A times A is A squared. Thank you for asking me.
And what?
Alright, let's try it again. 6x squared and 18xy cubed. 6x squared, 18xy cubed. Alright, so break down 6 for me. Matt. What? Say again. 3 and 2 and 1 and 6. Break down 18 for me. Christian.
3 and 6 and 1 and 18.
1 and 18, 3 and 6,
9 and 2.
9 and 2. There you go. Alright, so the largest number that's in both lists is obviously 6. Alright, now I've got to make decisions. I've got to choose from x squared or x. Which one has the lowest powered exponent? X. Y cubed or nothing. Well, in that case, remember, it's got to be in both. Since there's a y here, but there isn't one here, y doesn't go down to the solution at all. So we're done.
Did we have homework yesterday?
Oh, yesterday? No, no. All right.